Hello everyone, this is Osman Imam. Welcome to my channel Need to Know. In this video, I'm going to tell you what you would need to know about the technology of wind turbines farms. Humans used wind energy since very early times, starting with wind sails, then windmills, and finally wind turbines, up to wind farms today. Windmills first found in Parisia between 700 up to 800 AD. This is the Parisian windmill. It is completely made of wood. This is the global mean wind speeds map. The dark pink color shows the areas with highest wind speeds. It is clear that it is on the far north of the Earth, and some of it on Argentina and New Zealand in the south. Wind turbines technology is to harness wind energy and convert it into electricity. This technology has advanced significantly over years, focusing on efficiency, durability, and scalability to meet renewable energy demands. Wind farms consist of a multiple number with wind turbines placed in strategic locations, often on open land or offshore, where wind speeds are high and consistent. This is a wind turbine farm. A wind turbine is a basic element in wind turbines farm, and it is composed of blades, generator, control system carried by a nacelle and a tower. They are configured either Houts or Vouts. Houts means horizontal axis wind turbine. These are the most commonly used, with blades rotating through the horizontal axis, like this one. Vouts is vertical axis wind turbines, less common, used with blades rotating around the vertical axis, making them suitable for turbulent wind conditions. This is the vertical wind turbine. Boats recently advanced and found a wide application on local residential areas with a power in order of 10 kilowatt for it is a small area requirements. Finally, innovative Archimedes designs are emerging. With this design, the future of turbines or wind turbines is promising. These are the Archimedes wind turbine. Archimedes wind turbines do not need a complex control system. It actually automatically orients itself to the wind direction, which means it is very simple in design. Wind turbines use aerodynamics rotor blades to capture wind energy. As the wind flows over the curved shape of the blade, it increases lift, causing it to spin around its axis. Most modern wind turbines have three blades designed for optimal efficiency and balance. The blades are typically made from lightweight, durable materials like fiberglass, reinforced plastic, or carbon fiber. These materials are essential for durability and minimizing weight, as heavy blades can hinder efficiency and stress the turbine structure. This is a plate. This is a plate tip. Plate cylindrical root. Leading edge. Laminate cover. Internal reinforcement. Trailing edge. Plate root and plate tip light. The length of the plates depends on several factors. In areas where lower average wind speeds, larger plates are used to capture more wind. Conversely, in high wind, turbine may subject shorter plates or may subject shorter plates to excess strain. The span of the plate is directly related to the energy output. Longer or larger plates can sweep a larger area, capturing more wind energy. Larger turbines are chosen when higher power generation is desired. The design efficiency, materials, and technology of the turbine is also affect plate lengths. Advanced design can allow for longer plates at lower speeds. Environmental structure, cost constraints. Environmental factors such as proximity to buildings, wildlife areas, or aviation routes can limit the length of the plates. Also, of, the strengths of foundation tower. Larger plates means higher construction materials, specifications, and larger tower, which means high cost. So economics factors to balance initial investment must be considered. Transportation and logistics factors must be considered also. This figure shows a transportation means of one plate. It needs more than 70 meters trailer and a truck to transport one plate. With three turbine plates, that means we need three trailers with three truck heads. The hub connects the plates to the main shaft and the gearbox, allowing the rotation of the plates to turn the shaft. Modern designs use advanced engineering to reduce vibration, wear, and improve performance over time. This is a rotor hub assembly with plate tip, plate root, rotor hub assembly, a nacelle, yaw drive, shaft, the generator, electric circuits, pitch controller, and plate joint. And finally, the tower. The wind turbine tower is a critical component of wind turbine, designed to elevate the rotor nacelle high above the ground to capture consistent high wind. Turbine towers must be strong, stable, and tall enough to support the heavy equipment at the top, withstand dynamic forces from wind loads, and reduce vibrations. Towers' height typically range from 80 meters up to 160 meters, with the diameter at the base 6 meters and at the top 4 meters, and it is hollow from inside, give space for a ladder or even a lift to access the top. Most turbines use gearbox to increase the rotation speed from low turbine blades to the much higher speed needed by the generator. Some wind turbines use a direct drive turbine, however, eliminate the gearbox, which can reduce the maintenance costs and improve reliability. The generator is the high speed shaft from the gearbox turns the generator to produce electricity. This is a generator gearbox figure. Generators vary in type, with many modern designs using permanent magnet synchronous generators for higher efficiency and low maintenance needs. Individual wind turbines output is regulated and synchronized through the power electronics, converters, and control system within in each turbine. To ensure consistent power delivery, variable speed generators are used, such as doubly fed induction generators or permanent magnet synchronous generators. Each turbine includes a full-scale power converter. The converter has two sections, rectifier to rectify variable AC output to DC output, and the inverter to invert the DC output back again to an AC output. The inverter is responsible for setting out the grid frequency. Wind turbine control system is for yaw and pitch. Turbines have a yaw mechanism that rotates the entire nacelle to so the blades face into the wind. This system is often controlled by sensors from MDAS that detect wind direction and operates the actuators. While the pitch control is carried out through a signal from MDAS, also moving the actuators to pitch the blades or feathering the blade when winds exceeds the design limits. A collector substation is used to connect the wind turbine farm and harvest the farm while connecting it with the grid or utility. It has a SCADA, supervisory control and data acquisition, while each turbine has its own SCADA too. A central operation room is located near to the SCADA for collector and collector station, where the central SCADA server is located, processing all the data stored, display, and monitoring them. This is a collector substation. World's top 10 wind energy producers. Number 1, China, with 441.895 megawatts. Sorry. USA, number 2, 148.020 megawatts. Number 3, Germany, with 69.458 megawatts. India, 44.736 megawatts. Spain is number 5, 31.028 megawatts. UK, 30.215 megawatts. Brazil, number 7, 29.135. France, 21.196 megawatts. Canada, 16.989 megawatts. And finally, number 10, Sweden, with 16.252 megawatts. Conclusion. Wind turbines is wind energy exploitation is known since early times for sailing ships and driving windmills, until presently used by turbines to produce electricity. Wind turbines farms are facing real challenges, high initial costs, and logistic issues when it is manufactured. Offshore locations have a privilege than other places for steady and turbulent high wind speeds. It is possible to connect wind farms with solar farms to overcome shading problems during nights for solar panels. Archimedes model is an emerging technology for small plants and the future of wind turbines farms. Well, if you like my video, please give me a like, share, and subscribe. Thank you.